Hey there guys, this is Ryan, and today I'm going to be showing you guys how you can remake Mario, this little Mario game, in Python using my framework, PyDawgEngine. This is kind of the first time I'm really showing it off, at least in video form. I've shown it off a little bit on my Twitter, but I'm really excited to show this around. This is just a small little demo. It's got a little bit of everything. It's got player physics, it's got camera movement, it's got collision detection, it's got enemy AI, it's just whatever. You know how Goombas work. It's fucking Mario. You know how it's gonna go down. So we're gonna get right into it. You can download the engine in the description for my GitHub. Just make a new folder here. We'll call this tutorial Mario. Okay, we're gonna rename this section. We're just call it tut because it's easier to type quicker. I'm going to use the Mario assets, which means I can't really distribute most of this code, but I mean, I can distribute the code, I just can't distribute the assets, so put them in the right spot, and I'm not even going to bother re-importing them in, I'm just going to use them from, you know what I'll do, fuck it. I will drag that into there. Alright, and then we can make a new folder, we'll call this object, or we'll call content. So if you look here, we got all of our sprites. These are static sprites. These won't change. They don't have animations. But we do have the animations here. Yeah. You get the idea. It's pretty simple stuff. This one is different because it has multiple of the same frame, and PyDawgEngine currently doesn't support multi-length frames in a single animation. But you can set each individual. You could set the length of the frames of a whole animation, but you can't do each frame as a different individual length. So if you want to do that, you could just paste the same. You can just paste the same sprite. Let's go back to tutorial. Let's make a new. If you don't mind, I'm going to pull up the code on the other monitor because I'm an idiot. Let's make a new level. We'll make a new folder called. Well, first of all, we should make the game. So in Pygame, or PyDawgEngine, I should say, you need to make a game. We'll call it Tut Mario. It kind of sounds like a fake Tit Mario. Tut Mario, it's a class game. It should be, or no, we want to make it Tut Game. Class game. Import it. This is the PyDawgEngine game class. We'll define init. So we just made the class, we are initializing it, and we want to, on activate, do something. So this gets ran when the class is initialized, and then this gets ran when all the subsystems are fully initialized, and then we can actually start gameplay. That way we don't accidentally start the game without the display or the input started. That would be bad. So we will wait to actually do anything on that because we need to make the level first, and this is going to actually make the level. So I am actually going to quickly look stupid and move the, where is it? Should be here. Content, oh, game right here. I'm going to do myself a favor and move this to over there. And the level as well. So now I don't look as stupid. Okay. Because honestly, I don't remember the syntax all that well either, but we get there when we get there. So PDE is something that should be passed through to most objects when initializing them, things like levels. It really should be everything. PDE is just the engine. It's this file right here with this class. You're pretty much going to want to have this in everything. It's definitely the most important class other than main, which isn't really even a class. Technically it is, but whatever. You get the idea. So you want to pass this through to most things. It is a required argument because the game really you wouldn't be able to function this without it. So let me actually close out of all these just so that you guys aren't confused. We don't have anything weird going on. And let's quickly change the game to be the one that we just made. Ooh, fuck. Sorry. Tut game. There we are. So now if we load, we should do nothing. Or actually, it should just be blank, which is perfect because we haven't actually assigned a level to this yet. So why don't we do that? So, we want to do, well, actually, we should probably make the level. This is my first time doing a tutorial. I'm sorry, it's going to get really shitty real fast. Let's make a new folder and content, call it levels. we'll make another one called objects just now. So I'm going to be trying to split this up between the tutorial of making Mario and the tutorial of making PyDawgEngine. You might want to skip around if you just want to make Mario of your own framework, or you just don't want to use a framework, but I would highly recommend using a framework because it handles entities and collision and physics and all that stuff for you. And it's really useful. It makes these kind of things go by a lot quicker. So in levels, make a new file, call it, we'll just call it main level.py. It is a class level, or actually I keep forgetting, we need to name it this. We'll make it, we'll just make it Mario level. It is a type game, or not, no it's not, type level. Awesome, we'll have in it, and that's pretty much it for that. So just for now, we will change the background to be the Mario background that I have set, which is actually just a blue background, I believe, but it's fine. So after super, there's some things you want to in Pygame initially define before the super, and some you want to define after the super. So after the super, we're going to call self.change background. Oh, it's not level manager. It should just be level. Eebly. That could have been bad. Level. Where is level? Oh, from data.engine.level. Import level. Weird. Alright. So we do self.change background R for the type of string, and the path is data/Mario assets dot sprites sky.png. I shouldn't be saying dot, but I didn't want to stop. So I don't think we actually, we never actually added the level to the game, so we should do that. So for this, we want to do self.pde. We're getting PDE. We're accessing the level manager. That's why it's PDE so important, because that's where the level manager is actually stored. We're going to call change level. The level is going to be the Mario level. We're not actually using the class. We're going to make a new object. The manager, which stands for the level manager, is going to be self.pd.level manager. PD equals PE, or self.pd, I should say. Name, we'll call it main. And we want to activate it immediately, so active equals true. Can I import name? What are you fucking talking about, bro? What? Oh, it's duh. Okay, we're a little slow today. We're getting there. What the fuck? Okay. What? Huh? Explore? An unexpected keyword manager. I mean, should have. Oh, yes, it should have. We don't even need it, honestly. So we could actually just ditch that argument. It's not gonna work. Sorry, you can see down there. It's nearly midnight. What the fuck? Oh, because I put the arguments in the wrong spot. Kadershk. Okay, I apologize. We just need to put the PDE reference in these second parentheses here. Yeah. Now we do name equals main and active equals true. Might yell it makes it out of the manager, but No, we are fucking not, game. Is it because of this bullshit? Because I hate that. I don't know why it does it. Let's add in the manager. Level manager. Oh my god. Okay, well, we solved that issue. It's because we weren't inputting the right things. And why is that telling me it's not right? What did I spell wrong here? Let's try this. Looks literally identical. So let's try this. We'll go to Mario. Oh, because I moved the assets over. I didn't actually copy them. Let me copy and paste that back. Just there. Now it should work. There we are. There's our blue background. That means it worked. But just for the sake of doing it, we're going to change this to Tut Mario. Or what did I call it? Oh, I should call it Tut. Tutario. Tut. And it should still work. Yeah. So anywhere where it says Mario with capital M, if I leave it in there, it should just be Tut. But yeah, so after a little bit of debugging there, which I'll probably speed up in post, we got it. So yeah, 10 minutes in and we've got a blue screen. Nice. Okay. So now we can start doing the fun part. And so let's go into our tutorial content. Objects, we'll make a new folder. Player. We'll make a new file. We'll call it mario.py. And also Mario controller.py. That's a file. That's a folder. We want a new file. Mario controller. Let's make Mario class Mario. He is an actor in Pygame, or not Pygame, in PyDawgEngine, I should say. An actor is just an object that has world context, which means it has a position and a scale, and in Pygame speak, it means it has a rect. So from data.engine.actor non-action actor.actor import actor. Awesome. So let's see what to do first. So the first thing we're going to do is we're just going to test to see if we can get the sprite working. So after super, we're going to do self.components, because components, if you've ever used Unreal Engine, it's a very similar type thing. We're going to call it sprite. Components is basically just a bunch of mini objects that you can attach to an object and deattach them freely. It's pretty much just that. They update with the original and they get deconstructed with the original. I actually believe that you can attach other objects. I don't know if that's actually true or not, but I don't want to test it now, because if it's wrong, then I look stupid. But otherwise, we'll do the sprite component. And of course, it's not going to work. So from data.engine.sprite component import sprite component. The owner is self. The sprite we will load is, we'll do for now, which one of these would it be? Actually, these are here. We'll do idle left. So we'll copy this relative path, our string. There we are. And we'll put it on a layer. We'll just do one for now. And we don't actually spawn it in yet, so we need to do that. So in the main level, we will do self.man or we could do self.object manager. That's actually the right one. Add object equals to Mario. Did I just call it? What did I call it? I want to call it to Mario. You guys can call it whatever you want, but object equals tutorial Mario. And the arguments for this are, it should just be PDE equals self.PDE, manager equals self.object manager, and that should honestly be enough. If it's not, we can always change it, but yeah, look at that. We got Mario. He's hanging out. Not much else. Ooh, didn't mean to do like any of that. Yeah, he's there. He's big chillin'. Let's get him moving. Go to class tut controller in this Mario controller. This is a player controller. Of course, it doesn't fucking from data.engine.player.playerController import player controller. In it. There's really no need for most of these. I didn't really need to do that. Okay, so we're gonna do some things here. We're gonna do some cool shit. So PyDawgEngine already has some built-in input management systems. We have on input. This happens every time a button is pressed, and we have manage input, which is the input manager built in has a list, and this will run every frame. So if an input is in the current input list, then we do the thing every frame. So this is for button presses. This is for, I guess, just general input. These obviously both work with keyboard and mouse, so that is pretty cool. So let's get started. So since movement is going to be obviously in a while system, we're going to use manage input for now. All right, not even for now. We'll just use it permanently. If Pygame.k_write. So what this is, it's a Pygame thing. It's just a value for, I believe it might be an enum actually. Let's look at the top. I'm curious. Okay, it's not, kinda, I don't really know, but it's a thing, and it represents the right arrow key. If it's in self.owner, this is a long ass list, .pd.input manager, .key inputs, we'll just self.owner .movement 0 plus, or actually not, we'll just do equals 2. So let's just explain what we're doing there. So if Pygame.kwrite, if the right arrow key is pressed down, we'll get the owner of this component, because player controller is by default a component. We'll get the owner of the component, which will be our player. We'll get their movement, which is, think about it as like a wish list velocity. So you put whatever you want velocity to be in movement, and we will move that many units, or pixels I should say, that every frame. So we need to actually give this component to our player. So self.components PC for player controller equals tut controller owner equals self. That's actually all you need for a player controller. But that didn't work, so why is that? Don't think that should change anything, but interesting. So let's do some debugging. Print just anything Interesting. Hmm. 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 Oh, because I wasn't actually pressing the right buttons. I have the stupid. There, okay. I was pressing D instead of right arrow key. Okay, I have the stupid. It worked the first time. So, there we go. The thing is, he never stops because all we're telling the game to do is to set that to 0, or to set that movement 0, being the x-axis I should have mentioned, to 2. So we need to tell it to not do that. So else self.owner.movement how the fuck? Movement 0 equals 0. So now if we are not holding it, we stop. Look at that. Does all the hard shit for us. Not even that hard, but handles collision and stuff like that, so that's useful. Now we can do it the other way. So elif Pygame.k_left in self.owner.pd.input manager.key inputs self.owner.movement 0 equals -2. So now we can go both ways, and we don't even need to write another else. We move, we schmovin'. Awesome. Where are we? There. So here's a bit of a wacky little change. We can actually give him velocity. If instead of doing sets, we can actually add and subtract from his velocity, and we could see he kind of starts to zoom around a little. We should probably cap his velocity, but who needs it, honestly? I mean, look at how he zoomed. But you can kind of see it's not as strict as it was a second ago. He actually accelerates. I'll put that over there. And that's a good thing. That's exactly what we want. But there's a little bit more that would need to go on here. But we will actually get to that later, because I'm too lazy to do it now. I'm kidding, but am I kidding? I don't really think so. Just for this, actually no, that's fine. That's fine. We can keep that the way that is. So let's, what could we do now? I guess we could do the animations, sure. So the way we kind of set up the sprite here, it's just for testing. Or this is actually kind of a bad way to do it. You really want to have a separate sprite actor. The reason I say that is because having sprite independence or having sprite collision independence is kind of weird in PyDawgEngine, admittedly, but it is important in most games. And the easy solution to this is just creating a sprite actor. So tut Mario sprite actor, same thing. And instead, we put the sprite here, not there. Here. Then we need to define the scale of this. So we could do self.sprite equals put Mario sprite man equals self.man pd equals self.pd. Didn't mean to put a dot there, that should be a comma. Now that should pretty much just do the same thing. Yep. Except there's one big flaw here. We're not actually setting the position properly. So we're going to do def update. We don't return here. We should do this first. And then below that, we do self.sprite.rect.center equals self.rect.center. So in Pygame, general Pygame thing here, this is a rect. It's basically 2 position values and 2 scale values. So it's an X, a Y scale for both the horizontal and vertical scale. And this will get the math for the center, and we can actually manipulate that. So we set them to be the center of each other. and he moves again. Now we should probably do the collision stuff. So this should go before superinit. Superinit. Sounds like a thing. Sounds like a thing. Nice me. We can actually keep the defaults here. They actually do pretty well line up with this. It's 32 by 32, but here we do want to make this a little bit smaller. So let me just get the exact value here. So just to be safe, we should keep the scale. Scale equals 16. That doesn't. Well, yeah, it does. Self.scale equals. There we are. So we'll keep the scale at 1616. That should change nothing, as you can see. Oh, it changed something. Why did that happen? You know what? We'll keep it at 32. I say we keep it at 32. We're not going to talk about that. We'll keep it at 32. So now we can go over here, and in the actual tutorial Mario actor, we can keep scale. We can make it something different, and we will make it 16 by 32. So we pull up paint. This 32 by 32. Can I? Nope, that moves it. This is a 32 by 32 rectangle. We can fit. God damn it. We could fit all of Mario in this rectangle. Look at me. I'm doing this correctly on the first try. 32 by 32. We can fit all of Mario in here. So if we just kind of stick Mario in here, he can fit. This is pretty much what a sprite looks like, but his collision is actually something more like this. I know this is very crude, but it's fine. You can get the general idea. Don't want to save that. Never show that to anybody. His actual collision is going to need to look something like that. But if we keep it to scale, it really needs to look something like this. So an 8 by 16 box. Instead of 16 by 16. Again, do not save that. So we'll make it 16 by 32. Now you won't see much of a change here, but if I actually add a sprite to this as well, sprite, you will see two different Mario sprites. I should probably layer them properly. So it doesn't look like you can see it all that well. So let's change it to something different. We'll make it, we'll go into the debug assets here. Do me. So I didn't do self.scale equals self. Self.scale equals scale. So as you can see, that box of my YouTube channel logo is the real collision, while the Mario behind him is the sprite. And they're completely independent. So yeah, pretty cool. Just for safety reasons, I'm going to put self.check for collision on this to be false. But self.overlap should still be true. Actually, should it? No, it shouldn't. Self.overlap, check for overlap equals false. Just so that we don't actually do anything stupid. And we can put these here and set them to true. Now, also here in update, we should do that velocity capping so that we don't go kind of all over the place. So, if self.movement 0 is greater than 0, and why? That's kind of stupid. Oh, if it's greater than 0 and self.movement, so the same thing, is greater than 6, self.movement 0 equals 6. So we can actually copy this and do the same thing, but with negative numbers. And flipping the side. Flipping both sides. -6, -6. So let's explain what we just did. So if the movement at any given time is greater than 0, and it's greater than 6, the reason why having, it's always, if it's greater than 6, it's always going to be greater than 0. That's because if we're also doing the check for this, if we're doing the check for this and we take out both of these, it could be greater than 6, and then, well, really, I mean, I want to try something. So let's try this here. We're going to do a little experiment. Oop, whoa. Huh? Oh. Movement 0, self.movement 0. Gotta make sure you actually call it, because that's self.movement is just a full list, so you wouldn't be able to edit that. Yeah. So as you can see, works pretty well. Let's try something though. I don't think this will work. Okay, looks like it works fine and I'm just stupid. Got it. So, if the if movement is greater than 6, set it to 6. If movement is less than -6, set it to -6. That's our velocity cap. Now, if you want to see this work a bit better, instead of doing +2, we do plus 0.2. Now you can kind of see how icy we are, but it's actually pretty Mario-like, so it's good. Is that the actual value? Oh, it is. Look at that. So yeah, it's pretty cool. Now let's get this sprite animated. So for now, we can get rid of this test sprite box. We don't really need that right now. So we should add an animation manager to this. So self.components.animman equals anim manager owner equals self layer. We'll put it on the same layer, so layer equals 1, and sprite equals self.components. Sprite. Okay, of course we can't import the animation. From data.engine.anim.animManager import animator. So what an animation manager is it's basically, it manages the animations. We can give it a sprite, and it will change the image of that sprite to do what we want. So we can give it the sprite to edit, put the layer to edit it on, and we need to give it the owner because all components require that. Now, how do we add an animation? It's actually pretty simple. We'll save this to be self.sprite and self.animman. Naming conventions here. Never follow them. I've never followed them, I should say. You should probably follow them. So, here we go. We want to do self.animman.addAnimation. And here I am not following my own naming conventions by putting capital in a function name. Shut up. We need to give this animation a name. We will call this run rate. What you call run rate? Now we need to get the animation's path. The animation itself. I should probably rename that to be path, but frick it. So over here, I already have the thing. You want to copy the file, not the asset in the file. That's not even the right one. This is the right one. Copy relative path. Don't do any of those. Just do the whole folder. It's not a spreadsheet. It is a folder. Speed, this is the frame speed. Speed equals, we could do, this is kind of cool, we could do self.speed 0. Or, we'll do movement, just keep this one. We'll do self.movement. Or actually, no, it's already defined in super, so we don't even need to. And then on update, self.sprite.movement equals self.movement. So now they're the same. Let's see what happens. Nothing, because we didn't activate it. That shouldn't have worked. We need to set active equals true. Or actually, it's not even that. It's set equals true. Because we didn't do any of the speed calculations yet. I have the stupid. Let's define the update method for this class. We can do. No, why don't we return super.update? I don't really see a big issue with it right now. Being at the bottom. Let's just absolutely make sure that worked. I don't see why it wouldn't. Still works. Awesome. So let's do this. So what we've essentially done up here is we've added an animation state. And we can set the state at any time, and we will play the animation while that state is active. So if self.movement 0 is greater than 0, that means that we are running right. Self.components actually kind of fucked up a line up there earlier. Anim dot set anim state equals run rate. And make sure you spell it the same way as you defined it up here. Ooh. And we actually don't want this to be self.movement. I'm an idiot. We'll do 0.2. However, down here, we want to do this. Self.components. Or actually, we could just do the animan, can't we? Self.animan. Animan dot anims under the same name, run right, and we're gonna get, this is a list. It's a list of dictionaries, or not list of dictionaries, dictionary full of lists. We'll get the second argument. I didn't mistype that. We'll get the second index. So, or the first index. Like, I don't fucking know. You know how Python lists work at this point. We'll set it to self.speed 0 divided by 15. Why 15? It's just a good number. It makes it look nice. 1 in the list of information. I can actually show you. The first is the speed. So 0, 1. You can actually change an image of a. You can change the path of an image of an animation on the fly if you want to. Wouldn't recommend it, but you can. So that should have worked. No, it shouldn't have. We're never actually updating this. So you should always be adding things to the object manager. So we should do man.add object. So we're just kind of going. So that's a bit of a problem. So we'll do else. Because we're setting, this is why. We set the animation to true on initialization. So, because it needs a default animation. You can't have no animation if you make an anim manager. So we need to make an idle animation as well. So we can just copy this line. We'll call this idle, right? And it's under there. We're going to set this to false. Get rid of that. And we should probably put this on top. Else idle. So here we go. As you can see, it only works for the right, but it works damn well for the right. The animation speed follows the speed that we give it, and it looks pretty well. Looks pretty well. Nice. Nice, me. But now we can actually do the same thing. So idle left and run left equals idle left and run left. So if you wanted to be cool and stuff, you could use a loop, and you could use you could do a for anim in idle right, idle left, and then initialize these from that. I would probably recommend doing that if you have a lot of animations, but honestly, it just isn't worth it. Now we have those initialized, we just need to do a quick little elif self.movement 0 is less than 0. We could do this. You can just copy it, paste it, run left, run left. So this is going to kind of work. Not exactly, but as you can see, we do run to the left now. We do awkwardly pause. Oh, that's why. Can't have it be a negative value for the speed. So we actually want to do the absolute value of this. So that makes it, if it's a negative, do the positive. And there we go. Now we're going to notice if we run left and then stop, we snap back to the right. That's because we need to do direction value. So if self.movement is greater than 6, we can also do self.direction equals 1. And now we can do self.direction equals -1. Look at that. So now we do this. Self.direction equals, we'll just do 1 as the start, but yeah. Self.sprite.direction equals self.direction. So now those are all linked up as well. If self.direction equals 1, do this one. Or equals, I should say. If self.direction equals -1, set it to the leftmost. So if the direction which we set when our speed is to the right, set it to 1. If it's 1, do the idle animation for the rightmost. If it's a -1, do it for the leftmost. That should fix that issue. And I give a victory sneeze. Look at that. Now you are noticing that we are kind of stopping. Like if I let go, we just kind of freeze. And this is a complicated issue to solve, but I say we give it a go. We're going to go back to the player controller to do it. So actually, we do want to do a couple of other things. We need to define a couple of variable, actually just one variable really, before we do much of anything. And this will be important later. We need to do self.airtime equals 0. Now, I don't think this line is absolutely necessary, but we're going to keep it in because it works in my test that's working over off to the side. So, here we go. Here's the unmomentuming of it. If self.owner.airtime equals 0, which means that we are on the ground, essentially, is what that means. So I guess that is kind of important. If self.owner.movement 0 is greater than or equal to 0.2, which is the unit that we add or subtract our movement by. So if you want to change those values, I would suggest changing it here too. Self.owner.movement 0 minus equals 0.2. I really feel like that should be equal 0, but it's fine. So essentially what we're saying is, if we are on the ground with self.airtime, which we will change later, it's actually already currently 0 because that's what the default value is. And if we're greater than or equal to 0.2, if our movement is, we should say, slowly every frame starts subtracting 0.2. So this should do a thing. It actually doesn't do a thing, but I guess that's okay. Elif self.owner.movement 0 is less than or equal to negative 0.2. Self.owner.movement 0 plus equal to 0.2. So we're doing the opposite. Now, after we run that check, we could do if the absolute value of 0 minus self.movement or self.owner.movement 0 is less than or equal to 0.2. Self.movement 0 equals 0. Let's explain what I just wrote, because I really don't like to just write. So if the player's movement is greater than 0.2, so if we're adding 0.2 every frame, slowly start subtracting 0.2 from the movement. If it's less than that, start adding. So we're doing the opposite. We're giving ourselves some drag. And if the absolute value of 0 minus the movement is less than 0.2, then set it to 0. So what we're essentially doing is rounding. And we actually don't want this line. So that's probably what was causing that issue a second ago. Oop. Self.owner.movement. And there we have it. So we kind of be schmoovin'. And it looks pretty good. So if we want to add some gravity now, which would be the next logical step, we probably need to add a ground for the player to stand on. So let's make ourselves some ground. Make a new file, or a new folder, I should say, over here. We'll call this tiles. New file, we'll call it ground tile.py. Now, I don't actually have a tile loading system like from a text file, but that's something pretty easy to make. There are a lot of great tutorials on that. But we can just use a simple for loop. So we'll do class ground tile. Type actor. There's no way it lets me import this properly. Oh, is it actually? Oh, it is gonna let me. Wow, that's cool. Def init. We should doing the position on. We should probably put in a scale. So scale equals 32 by 30. It's a list. So scale equals. And we also want to do self.check for collision and self.check for overlap. We don't really need a direction. We can do super now. We'll give it a sprite self.components sprite equals sprite component equals self sprite equals, and then I'm honestly not looking forward to typing that out, so we're just going to copy it and change this to ground.png, and we'll put the layer on 2, and we actually have to import this. Now that actually is it, other than one more thing. Having this actor update every frame, trying to get new collision data and stuff like that, it's such a static object that ground tiles never move. We actually just want to remove the update method entirely. Instead of that, we're just going to pass. Or actually, we should just return. I believe that's faster. This is just a huge performance boost considering how many of these we're going to have, and you're going to want to do this for most static tiles. Unanimated, really only there for collision. Hell, even background, if you want to set check for overlap and collision to be false, it's even better that way. We will do that later for the background tile. Let's see here. So we'll go into the level. And we're going to spawn these in. So, on initialization, for I in range, so for every number in this range that we're about to create, and this range method just creates a list. We'll get ballsy here. -100, 100. So we're going to be making 200 of these. So you can kind of see the performance gain that we're going to see here. So this, let me rename this to R. So think about it like, this is what's called a two-dimensional array. If you've never heard of this, this is a pretty important Python/math concept. So let's say we have a list. So these are the rows, and then within each of those, we have another list that contains, we have a big box, a list that contains, and each box contains 2 boxes. So these are rows, and these are the columns. 2D array. So for R in range, that, and then for column in range, 1 to 3. Now this is, normally you do 0 and 2, but I'm going to explain why we are not going to in a minute. Self.objectManager.addObject. I know it kind of looks like I'm looking off the side, and I am, admittedly. I'm looking at the code that I already wrote. I don't want to make it look like I'm copying somebody else's. This is all code that I've already written for this. It was in the test that I showed you at the beginning. So I may look like I'm trying to hide it, but it's honestly just so I don't look stupid, because honestly I don't remember most of this code because I wrote it a really long time ago. I was like, hey, I should make this into a tutorial. So now we're doing it. Ground tile. We'll do man equals self.objectManager. PD equals PD. End position. This is the math part. Equals the row times 32. And this is the dumb one. 492 minus C times 32. So let me just show you what this does, and then I'll explain why we do it. Or not, because I did the silly, it's not position, or why would it not be position? Huh? Ground tile, oh, because I'm the stupid. Accidentally imported a library that we don't want up here. Okay. So there we go. We have the ground tiles. Now let me explain what we just did, because it is a thing. So as you can see, we're pretty much operating equally as we were before. And there is 400 of these. 400 of these ground tile objects. Now let me show you what happens if we go back to the ground tile and we actually delete this override of the update method. We are going to fucking lag. Because if I go to the default actor, in update, we do a lot of things. Where is update? We check the lifetime, we get the overlaps, yada. And then also, in object, we update all the components. There's a lot of stuff going on in update. And it's also just a lot of things for the object manager to keep track of. So because we don't really need tiles to update, just simply returning instead of doing any sort of calculation here removes so much for the engine to do in the back end that it's actually a huge performance boost. So I would recommend doing that if you have solid tiles that don't do much. But hey, the collision would work if we put them up there, or if we put Mario down there. So let's put Mario down there. And the easiest way to do that is just an update is we will do self.movement 1 plus equals 0.35 is a good number. as you can see, we are on the ground, and I'm gone. Why did that happen? So if you guys are actually familiar with Mario 64, the way that their collision works is it does a series of checks. While PyDawgEngine's a little different, it's basically the same idea. Think about it. We are not actually adding to our position here. We are adding to a velocity value, really. So eventually this movement value will add and add and add and add and add, and eventually it'll be a number so large that adding that to our position would stick us past these ground tiles. So we just go right through them, and we would end up on the floor of these. Now let me explain this for loop that we made. It was in the level. I have the stupid right here. So the reason we do this dumbass math is the exposition makes sense. The exposition makes sense. Because the tiles are 32 pixels large, we need to offset them by 32 pixels to actually make them appear on the screen. That makes sense. But why such a specific calculation here? That's because if we were to Google a picture of Mario, I will... could I just get away with showing it right now? I will. Please don't show when I'm watching on YouTube. Okay, cool. Let's do just Super Mario 1-1. As you can see, when Mario's on the ground, it shows half of the bottom tile and then a full top tile. It's exactly what we have here. So the math to do that is the way that Pygame works. Let me actually run the game and use snipping tool and grab a screenshot. So this right here is 32 pixels. And the size of the PyDawgEngine window is 480 by 640. 480 by 640. So that means, because of some Pygame weirdness, stuff that I do not control, normally if you were to look at this as like a graph, this down here would be 0, 0. But that's actually not the case. Let me grab my eraser tool just to erase this. This up here is actually 0, 0. And this down here, this bottom corner, is 480 by 640. So a 32 pixels would land us right here if we were to spawn them normally, which we don't want. So we need to get half of this. So that's 16. We subtract that from 640. Or actually, we would add that on because, think about it, if we subtracted it, we would be over here. And this, we would have an empty row right here, and it would actually be right here. And here would be where the floor is. And we'd have some rows down there that we don't want. So if we instead add it on, we spawn the first row halfway outside of the player's view, and then we could spawn one directly on top. And that's why we actually use 1, 3 instead of, if I show you 0 and 2. Due to the way the math works, it'll spawn it wrong. Let's think about it. Because we spawn it at this, if we did 0 for a column, because 4C in range, so C is 0 for the first one. C is 492 minus 0. So it would just spawn at 492, which is right there. Because if it was at 480, it would spawn normally, and it works. But that still doesn't fix the issue, no matter how hard I explain things that probably don't matter, that most people can understand. What am I doing? Where? Oh. Let me just make sure that that actually works. Okay. Now we need to fix Mario just doing a his funny little teleport. And let me be an idiot and try to find where I did this originally because I have stupid. Okay. Now let's do a thing. If we'll start it right here. So the first thing we should really do at the top is that. That's probably one of the first things we should do, just for calculation purposes. Then we're gonna mess with the collide info a little bit. So Pygame automatically tracks collisions, or PyDawgEngine, I should say, because Pygame doesn't do that, but it's cool, I promise. So before Mario disappears, let me explain. Currently, the bottom of our collision rectangle is colliding with the top of the ground. And there's an internal list that actually I can show you if I turn debug mode to true. And I really quickly... Where is my mouse cursor? What the fuck? We're not hiding mouse cursor. Why would it not show up? Is it doing that by default? Why? That's kind of fucking weird. Let's take a look at the display manager, I guess. That's a bit fucked. Okay, well, I think it's just my weird-ass computer being a weird-ass computer. But if I could click on Mario... Actually, you know what we can do? Let's take a look at the on input system. So, the on input system. So, if input equals Pygame dot k underscore space self dot owner dot print debug info, I believe is the method. Yes, I did mean that. Again, me not following my naming conventions is biting me in the ass here. Real hard, because it's a method and shouldn't have space, whatever. But if I press space, we can actually see the information. So as you can see, our movement value down here is really fucking high. And we can go right through the floor. And that's our position value. So we're just a little bit below the bottom. But, as you can see in our collide info, if I do it right here and here, and here, on our collide info, bottom is false, and this third one, when I hit the ground, bottom is true. And we're colliding with a ground tile object. So it actually keeps track of all that stuff for you. So here, we can do if self.collideInfo bottom. So if we are colliding, if our rect is colliding at the bottom with anything, set self.movement 1 to equal 1. I didn't mean to hit shit enter. Damn it. And then we could do self.airtime equals 0. And if we are not colliding with the bottom, self.airtime plus equals 1 every frame. So let's think about what we just wrote. If we're touching the bottom, if we are being touched at the bottom, we are going to set our movement wish, as I'm going to call it, movement intent, to 1. We're going to try to hit the bottom. And the reason for that is if I show you here, our collision is going to look pretty normal. This is because the way collision works is checks to see if you are inside the object, even by just a pixel. If you are, or if you would be, push you back out. Now, if we set it to 0, we would go to 0, float to the bottom, float to 0, or go to 0, float to the bottom, and it looks really choppy and weird, and we don't want that, because professionals have standards. By setting it to 1, we could do a little bit of funky math later on, and it'll look normal like it does now. And also, I should mention, space bunch, our movement is 1, we're not teleporting through that ground anytime soon. And now our airtime also goes up if we are not on the ground, because it's our time that's in the air. Now, just to take care of something that would happen later, if self.collideInfo top, so if we're colliding with top, self.movement 1, so our y value movement equals 1 as well. because if our head hits something on the top, reset our velocity, send us back down. For the last of the collisions, we can do if self.collide info left or self.collide info right, because these are booleans, it's predictive bools. Self dot, so this should be movement 0 equals 0. Cool. Now that is that. I say we add in some jumping. Jeez, these allergies got me fucked up. Okay. Let's make a new method. Def jump. And I do self, and that's really it. If actually, you know what? I'm gonna explain something first. We're just gonna do something relatively simple here. Self.movement 1 equals, bear with me here, -9 plus the negative of the absolute value of self.movement x divided by 10. Now if I show you what this does, is nothing because I didn't actually bind anything to that yet. So if input equals Pygame.k underscore up self.owner.jump. What did I do here? Movement. Still not doing anything. Why? Why would that be? We are not doing anything. So it looks like it's trying to jump. Puts me at movement 1 for a little bit, or is it ever not movement 1? I feel like it wasn't not movement 1. That's a bit strange, I would say. Did I fuck up the formula somehow? Well, there's a random ass parenthesis there, so, oh wait, well it's not a random ass parenthesis, it goes that absolute value. Let me just copy this, and maybe I fucked it up. Oh, okay, I must have fucked it up. How did I fuck it up? What was different there? Just so that I know. I'm a mess. Holy shit. Okay, was there literally no... What the fuck was happening there? Doesn't matter. I guess I don't think I actually saved Mario Controller. But as you can see, it works. Works just fine. Oh, I know why. It's gonna do that thing again. There is a failsafe for this. We will get there when we get there. But as you can see, we can jump in the air, but the second we hit the ground, we can't jump. So let's add this line. First of all, we'll do this. If self.airtime is less than 6. Do it. So as you can see here, we can't jump at all now, but if I can get the timing right within 6 frames, that's definitely not going to be it. I want this now. There we go. I can jump once because it's within 6 frames. So that is a bit of a thing. But if you got the balls, just set airtime to be greater than 6 when you spawn. It's just that simple of a fix, but I'm not going to bother with it. So to fix that thing we were having before, what is the thing that I need to do here? Because to be honest with you, I do not remember, and it was a pretty big issue. I remember it being a big issue because it was a pain in my fat ass trying to fix. Oh, we need to do the collision code first. That's why, before any of this calculation. So actually, we do want that to be at the top. It's because we're not doing collisions at the right time. Aha. I remember this was an issue. I actually messaged a good friend of mine, DeFluffy Potato. We played competitive Pavlov together. He's got a metric piss ton of subscribers on YouTube. Please go check him out. He has helped me in DMs countless times when I simply do not deserve it. So, he's a good guy. And I remember being in a chat with him for a long time over that. So, the real reason is because we need to do the collision checks before we do any of these, like actual collision detection. Because if we do this, we're doing it on a collision from a frame from the past, which we don't want to do. That's kind of not good. Yeah. So that is a lot. Actually, I think that's just Mario's physics down. Yeah, we can get on to some of the other stuff. Let's do the background now. So let's run into here, the background, and by background I mean like the plants and trees and stuff. It is relatively simple. For our in range, now you want to try and limit how many of these spawn in because they can get laggy. So we'll do -1 to -2, or we'll do -2 to 2. Self dot object manager dot add object, and we're gonna keep that there for now because I'm an idiot. And I am stupid. Let's add a new object under tiles. We will make this new file background.py. Now this is going to be another relatively simple. Actually, you know what we can do? We can honestly just copy this. We'll call this BG tile. The scale and the position are going to be a bit different. We're going to do 320 by 240, so it's dead center of the screen. And the scale is 2096 by 480. Let me show you the reason why. It's because this asset, this path right here, it's actually BG. Assets, sprites, BG. This thing is relative. He's a long boy. And that's because in Mario, these are actually set. They're split, like where my mouse is showing right here. I can do a better example if I just do this. They're actually split about here and here, and they're kind of stitched together. And in all honesty, I didn't feel like dealing with the math required for that, even though it's pretty simple. So I just kind of stitched them all together, and that creates a pretty large file for Pygame standards. So having in too many of these in one level can get a bit risky, so I wouldn't recommend it. But that's why we're only spawning a couple of them, and it lasts horizontally for a really long time, so we shouldn't really have to worry about it. So that's actually it. We could just copy what it was for the tile. Go back to the debug level, or not the debug level, just the level. And, ooh, that's not the level. I have the stupid where is the level. Oh my god. BG, what do we call it? BG tile, manager, and honestly, we could just copy over these. And, ooh, don't write the state of that. And we're gonna do position equals, what was that? It was 2096. 2096 times R 480. Or it might be 240 actually. I believe it's 240 because we're spawning it. The origin of every object. This is different. Okay, we're a little off. Not gonna lie. Just a tad off. Maybe it was 480. What the hell was it? It's actually -48. Let me explain why. Yeah. And I actually did forget to do something pretty important. We need to turn off the collision. The collision is still on for these. And there we are. So we're also on the very wrong layer. So we are going to put that behind us. If you get what I'm saying, I'll put that on 1. We are actually still behind that. Let's change Mario's sprite layer to be more like 3. We want to be ahead of most things. And that's actually that. However, we can't really see most of it. It's back there, and the reason it's 40, by the way, is because it's 32 for each brick, plus brick and a half, so it's 42. 32 plus 16. That's not even right. Oh god. Yes, it is right. Oh my god, I'm literally. It's fucking 1 in the morning, bro. You gotta cut me some slack here. So I guess that means now we should probably do the camera movement, which is actually really simple, thanks to yours truly and PyDawgEngine. It's actually really easy. It's actually one function, really. On update, self.scroll camera to center. This can be applied to any actor, and it will scroll the camera only horizontally. It has vertical potential, but I'm going to separate those for the final release, so scroll camera horizontal and scroll camera vertical. So you can mix and match them as you want. But yeah, we can actually scroll the camera, and we can see that everything is rendered beyond the point that we could see at the beginning of the level. So yeah, there's the ledge, and just to show that the collision is real, whapa, we are in the void. Now, that is kind of concerning me. You know what? That's fine for now. It is fine. So, that only leaves a couple more things left to do. Let's first of all do this. So, as you noticed, Mario doesn't stop accelerating when he's in the air. If I were to let go of all these buttons, he just kind of keeps going. Let's make it so that he decelerates at a different rate. We can actually just copy and paste this code, and this is the reason we have the air time, because if air time is not 0, that means we know he's in the air. So we could just lower these values a little bit. And now it's a lot better. So yeah, that is working really, really well. Let's see now, what could we do? That's actually only leaves a couple more things. Let's do the question blocks, because this question block issue was the thing that made me decide I want to do this tutorial in the first place. It was such an interesting thing, and I actually learned something really important about Python, and I kind of want to share that information with you guys. So let's go back to objects. We could do new folder. We'll call this blocks. It kind of looks like we're making Minecraft here. We'll make a new file. We'll call it qblock py class item block of, again, type actor. You're gonna be seeing a pretty common theme here. Mostly gonna be actors. Now, for once in our damn lives, the arguments here are going to need to be a little different. So we'll have the normal, you know how it is, position, and scale, and we're also going to have items, and its default is going to be none. Now, if items is, if items is none, then self.items equals that. Or no, we should do items equals that. Self.items equals items. So you might be wondering, well, that's kind of stupid. Why are you not just putting items as a default value like that? And that's due to an issue with mutable lists. In Python, a default value is only instantiated once, because this is really an object. It's an object of type list. And that is only instantiated once when this is defined, not when we instantiate each object of this type. So because of that, if we were to edit this, every single object with that argument would also get it. So which means when we hit the question mark block and we removed something from this items argument, it would get removed for all question blocks. And this took me a really long time to figure out. But I finally got it, and it makes sense because I Googled it after the fact. But yeah, thanks to some rando on Discord for helping me figure that out. Took me a while. So let's do this. So we do want actually, you know what? That's probably fine. So here's what we'll do. We need to do a couple of other things. Self.check for overlap and collision. Collision equals true. True. Just kind of a fun way to do it. Self.position equals position. I sound like a Kanye West song. Self.position equals position. Self.scale equals scale. And we do not need a direction. I don't know why I have that over on my other monitor, but I do. Self.components sprite equals this. I'm not typing that out. It's pretty much the same thing we've already done. I'm going to be honest with you guys, but this should be... I'm not going to lie, did not feel like typing that out. I probably should be typing most of it out, though. That's just not professional, and professionals is standard, so... Self.components. This is, I picked the actual longest line. Animan equals animManager owner equals self layer equals 2. It's a good layer, and sprite equals self.components. Sprite. Okay. Now we can add in the two animations. Again, don't really feel like typing these. Just copy and paste them. These should be tut and tut. So we have that. Now let's go over the collision code. Def collide. Now this happens on collision. So as opposed to the while collision that we were looking at down here, this is on collision. Now we get an object and we get a side that the collision happened on for us. So if the object class, this is a, by the way, downright deplorable way to do this, but fuck all if I care. If object.class equals tut Mario, which is the player that we made, we do not want to put parentheses because that will cause us to make a new object, and that would be bad. And side equals bottom. And if the length of self.items is less than 1, or less than or equal to 1, I should say, self.components animan, I completely forgot these are animan and animan. Self.components animan.set animState state equals empty. So here's what we just did. If we're collided on the bottom by the player and the length of items, our item list, is less than or equal to 1, because if it's 1 and we hit it, it'll be 0. So we go down. But because this is only ran a collision, it would never detect that. It went to 0, and we would do nothing. But also, if there's only one object in there, we go to 0, then we also want to set the state of the animation to empty. Yeah, that's correct, because I'm always correct. And if the length, again, of self.items is just always greater than 0, or at all greater than 0, self.items.remove self.items 0. So that removes the most recent object. So reason why this is a list is because in Mario you can actually have more than one object in a box, like multiple coins, which are randomly generated. You could here with this system have as many mushrooms, as many coins, or whatever. I haven't gotten into items yet. I'll probably make a part 2 that includes items, but I don't have them here yet. But that's actually the entire question mark block. Let's go down to the level. Self.objectManager.add object. The object equals, I believe we called it item block. Yep. Manager equals man PD equals PE, or I should do manager equals self.objectManager. It's better off that way. PD equals PE. The position, we'll just do, I don't know, what's a decent position I could do? Do like 200, 200. And that honestly should be fine unless it like spawns in the ground. And what was the issue with that? Oh. Q block position equals 0, 0. Scale equals 32. Not 43 or 43. 32 by 32. First try. Okay, a little off, but we actually can't reach that. Let's make that a little bit closer to the ground so we can do like 280. Whoop-pot, and we crash. Oh yeah. Oh, I did Aim Man. Aim Man. The newest superhero. He sounds more like a villain. Aim Man. There we go. So that's actually it. Oh wait, no, the Goomba. I have the stupid. I have the stupid. Completely forgot about the Goomba. It's actually relatively easy. But you get the idea there. Let me also put this on, we'll make another item block, so we'll do another one of these. And I want to put it more like at 100, and I want to do it, I want to put it 480. So it will be not 492. It'll be 480. Fuck, I'm so bad at math calculator. This is kind of embarrassing, but let's do 480 minus 32. 448 minus 16. Yep, and that's where I want to spawn it, so 432. Where we're gonna put this in like layer 5 just so I can actually see if it spawned. Oh, it's like in the ground. Nice, me. Real smooth there, but we should probably throw this on 200 just because it's like in line, I believe. It's not even in line. Oh my lord. And we actually want to put this at more like 420. Oh yeah, we're blazing it. Just to show we be colliding, and it's a little funky. I'll probably fix that in the next episode because I don't really remember what's causing that. But it does show that the collisions on the side work as well, so that's good. And I actually do want to move that up a bit more. We could do like 480. It's like 380. All right, good. So I did that because for the Goomba, it's going to hit a wall and then turn the other direction. Just so I can show you guys how to do that. Objects, we'll make a new folder, call it enemies. We will make a new file, call it Goomba class Goomba, and I'm naming these because I already have classical Goomba and stuff. I just don't want to risk it, like overriding or something. Def init. Let's run over to where I'm actually keeping that. Okay, so there's a lot of stuff going on here. We actually need to copy over most of the physics stuff. And to be honest with you, don't really feel like rewriting most of that. So here's what we're going to do. We're just going to copy this. Put it in the Goomba. So Goomba. Let's just change these. Yeah, but it looks fine. So that looks fine. We actually do want to get rid of the player controller. That would be really dumb if we kept that there. But actually, that's really it. It should fall to the ground, but otherwise, the easy way to make this work would be... Oh, and we also want to get rid of the scroll camera. We don't want it scrolling. Let's do this. Self.direction. We actually... we need to do this. With 0 equals 2. Or, yeah, for the little there. Equals -2. So here's what we did. If the Goomba collides with the left, we actually want to flip these values. If the Goomba has a collision on the left, he will start moving to the right. If we have a collision on the right, he'll start moving to the left. And we need to we'll do this at the self.movement equals 2. Now we need to go to the main level, and we can honestly spawn them at 0, 0. So self.objectManager.add object equals to Goomba and equals self.objectManager PD position equals and then position equals position. And we can delete that line as well. So that was just a general thing. What the fuck? Oh, there's no M. Not equal 0. So the issue there is that we don't really have a thing, so we'll do walk, and we can actually get rid of this line entirely. So if the movement is not equal to 0, so if we're not standing still, set the animation state to be walking. What the hell? Oh, well, duh, because movement, yeah, I instantiated it wrong. Movement 0 equals 2. Here we are. So this dude We'll walk. We can kind of chill on top of him. But if we get collided with, or if he collides with any object really, he'll turn the other way. So let's wait for him to come this way. And he hits, and he turns around. So now we should probably do the squashing bit. So that was mostly just a copy paste of the player. We can remove the player controller, and we remove most of the player specific stuff. But this works pretty much identical to a player with the same physics. I'm probably going to end up making an in-engine physics component that'll handle most of the stuff for you. Just because this is kind of stupid to have the user do this. I mean, it is good practice, admittedly. This video would probably be like an hour shorter, which would be nice for you guys because this video is kind of shitty so far. But what are you going to do? So we need to add the death now. So where is def on collide? Def collide. So on collision, we can delete this line. On collision, okay. If object dot class equals Mario, as I've said before, that's a horrible way to do that. Shouldn't be doing it like that. If side equals top, we'll do self.die. And there currently is no self.die with it, so we'll make one. Def die self. Now, if we're not already self.dead, damn it, didn't do that. Then self.dead equals true. And we actually did make a self.dead, so we'll put that there. Self.dead equals false. So if we're not already self.dead, kill yourself. Nice. Then self.sprite or we do self.animan. Do I have an animan? Self.animan dot set anim state equals dead. Now that shouldn't really do much. Why does it? Oh, self.sprite. All this should really. Oh, it doesn't even do anything. What the hell? Oh, and then if not self.dead or self. You know what? Let's do this. Self.owner. Owner equals self. That way, if not self.owner.dead. We only want to update the animation if we're not dead. What the hell? Oh, we need to actually self.owner equals owner. So now, yep, he's going to get squashed. We also, on death, want to do self.movement 0 equals 0. Now, he will stop moving when we hit him in the head. Awesome. Last thing we need to do is do self.check for collision equals false. Actually, I forgot. We don't want to do that because he'll fall through the floor. So we also probably want to do self.movement 0 or 1 equals 0. Still not good. It's fine. I don't even do this anyway. And actually, we don't want to because of the thing we're going to do later. I just remembered, so don't even bother. And the last thing we're going to do is on update. We'll put it right here. If self.dead, so if self.dead is true, we need to do self.dead ticks equals 0. So we're going to make a new thing called dead ticks. If we're self.dead ticks plus equals 1. If self.dead ticks is greater than or equal to, how many frames do I have here? 20? Then self.sprite.deconstruct and self.deconstruct. Now what deconstruct does is it fully removes the object from memory. So there we go. That's it. That's the Goomba. So I plan on doing a part 2 for this, doing a couple more things, like getting the jumping animation to work, which I have over on the other one, but man, it is an hour and a half long. I want to upload this and be done. We could do the bricks. We could do a couple of other things. We could do actual player death, but it might be a while until I actually get all that stuff done. We could do the jumping on the Goomba makes the player jump up, which you can manually do. I mean, technically, it doesn't count the Goomba as a non-floor object, so you can do that. But yeah, that's really all that needs to be done for now. If you want to challenge yourself, try and get it done before I can get it done. Go for it, and then let me take your code now. But yeah, that's a pretty early introduction to PyDawgEngine. I want to do just a general PyDawgEngine introduction, but this is also a pretty general Pygame introduction as well, if you have a framework and you can kind of correlate what most of the stuff does to it. But yeah, that's the first intro to PyDawgEngine. So yeah, let me know if you guys think this sucked, and I will see you guys later tomorrow, man. It's so early. I want to go to bed. All right, bye.